The basic components of a lathe: the headstock, the tailstock, the bed, the saddle, the cross slide, and the compound. The headstock of the lathe is used to supply power to the machine to turn the part and also supply a point of attachment for fixtures for holding the workpiece. The tailstock is used for supporting long workpieces or for making features in the ends of workpieces. For example, we have a drill chuck in place here used for drilling holes in the ends of workpieces. Riding on the bed of the lathe is the saddle. This allows us to move tools along the sides of a part. The cross slide allows us to move tools across the face of a part. The compound is held down with 2 or more bolts. Loosening these bolts allows us to rotate the compound to a desired angle and then allows us to cut tapers in parts. I'll review the parts of the lathe in this illustration. Here's the bed of the lathe. The headstock is at one end of the bed. The tailstock, shown here, can be positioned anywhere along the bed. The saddle also rides on the bed of the lathe. The cross slide is built into the saddle. It moves perpendicular to the bed. The compound is mounted on the cross slide. The direction of motion can be set to any angle. Tool holders are usually attached to the compound with a T-slot, shown here. All of the axes of the machine can be operated by hand, but for many operations it's desirable to use a power feed. Demonstrate that feed now. With the machine on, have a lever somewhere on the machine. You'll often, on a new machine that you're not familiar with, have to look for this lever. There are no standards really associated with the position these levers or how they operate. What I'll now do is engage the saddle feed. You can see by the motion of the wheel, the saddle is moving along the bed. Put the lever into neutral. On this particular machine, I have a knob here that allows us to change the direction of the feed. Have a similar lever for the cross slide. Engaging that as a cross slide out. Again, changing direction. And we can drive the cross slide in. The third axis of the machine does not have a power feed. The compound is often used for machining tapers on parts. The base of the compound is marked off in degrees, allowing you to set the desired angle on the compound. Tighten the compound in place, and the compound is then fed by hand. With some practice, and using both hands, the compound, it's possible to maintain fairly constant speed and get a smooth cut. The cross slide can be accurately positioned for the use of this dial. But on most machines, the saddle does not have an equivalent dial. What you generally use with a saddle is a dial indicator like this with a stop. You bring the dial indicator in contact with the stop so you know where you are on that pass. You can then adjust the micrometer so that you can take a deeper pass, for example, we want to go another 10,000ths of an inch on the next pass. Set the stop there, come down, and when we're machining, carefully bring the saddle down until the indicator indicates 0. An alternative to the dial indicator mounted on the saddle is what's called a saddle stop, which is generally a micrometer adjustment like this that is clamped directly onto the bed. Many different types of tools are commonly used on the lathe. This is a standard lathe tool. These tools are commonly held in lathe tool holders. Install the tool, make sure the tool holder is clean. Tool in place. And lock the tool down securely. What I have here is a typical array of tools for a prototype shop. We have the tool I showed you, which is a general purpose turning tool, tool used for cutting plastic, cutting in this direction. Then we have a couple of boring tools. Very small boring tool for making very precise holes. Here's a larger boring tool. Another turning tool. This odd tool is for knurling, for roughening the surface of a tool typically so you can get a better grip on it. This tool is a cutoff tool or a parting tool. Its long, thin blade is used for cutting off pieces that you've made from a larger piece of stock. This tool, very similar to, say, these tools. The difference is the angle, the face of the tool, the top of the tool here, you can see it from the side, is tilted this way instead of this way. This allows you to cut in this direction. This tool holder is used to hold tungsten carbide inserts. These triangular inserts can be used when the end gets dull, remove them, and rotate them, and you have another fresh tool to work with. All of these tools are held in this tool holder. Placed together like this, there's a cam lock. You can see it's moving up and down as I turn the handle. Bring it into the up position, put the tool holder in place, turn the lever, it expands inside the dovetail and locks everything in place. This is very convenient because it allows you to do work with one tool, remove that tool, put on another tool, remove that, come back to the original tool, and this tool will consistently return to within 2 or 3 10,000ths of an inch of the position it was in the first time you used it. This is set up with a T-nut. We slide the tool post in place in the compound. Lock it down. Then lock the desired tool in place on the tool post. I have just cut this piece of stock from a larger piece of bar stock. Used a bandsaw. So you can see here that I've cut it reasonably square to the sides of the stock. The surface is rough and it is not completely perpendicular to the side of the stock. So I'm now going to put this in the lathe and face the end of this part. And in doing that, I'll produce a very smooth, flat surface that is also perpendicular to the sides of the part. I'm going to make sure you've got the piece locked securely in the chuck. I have here a facing tool. You can see the top of the tool is angled like this so that when I cut across the face of the part, the chips slide off the tool nicely. Lock the tool onto the tool post. Bring the tool in front of the part. Bring the tool close to the part. Turn the chuck just to make sure that nothing is going to collide with anything else. That may be the tool hitting some part of the piece you just put in here because the cut was irregular. It may be parts of the chuck, often the chuck jaws, hitting other parts of the lathe. So always turn the chuck to make sure that there's no interference before turning on the machine. Now bring the tool down. You can hear it's just contacting the part. And back the tool off the part and then move the saddle down. In this case, we'll be taking a roughing cut on aluminum, so it's reasonable to take a cut of 50 thousandths of an inch or even as much as 100 thousandths of an inch. For the first cut, you should always at least start the cut by hand to make sure that nothing surprising is going to happen. You may have forgotten to tighten the tool properly. The person before you may have not tightened the tool properly. Now you can see this surface, even though that was a roughing pass, is now much smoother and flatter than it was before. Before removing the chips that you've just made from the machine, always stop the machine. These chips are essentially like little razor blades. In fact, Gillette makes razor blades in just this way. So with the machine off, then it's relatively safe to come in and remove the chips. However, for example, some of the chips are hung up on some part of the machine. If you pull too quickly, you're still likely to get hurt. So be very, very careful with chips like this. Now that we've finished a roughing pass, we can come in just another few thousandths of an inch, take a finishing pass. This pass will do with the power feed. Gives us much better control over the speed of the cut, which results in a flatter, smoother surface than we would get by feeding by hand. The last operation involved in facing a part is to break the edge. You produced a knife edge here. It's very dangerous. There are a couple ways of dealing with this. One way is to turn the tool and just bring the tool into contact lightly with the edge, breaking the edge and making it safe. This can also be done with a file. Be very careful with a file. With shorter parts, it's very easy, if you're not careful, to get part of the file caught up in the jaws of the vise. I have a piece of stock here, slightly larger in diameter than the finished diameter of the part that I'm going to be making. So what I'm going to do now is put this part in the lathe and turn down the outside diameter of the part to the desired dimension. Start by locking the piece firmly in the chuck. The tool I'm going to be using for this operation is called a right-hand turning tool. You can see that the top of the tool is tilted to an angle like this, so that as you're cutting in this direction, the chips come down onto the tool and slide off the tool nicely. Start by bringing the tool close to the part, then turning the chuck. Doing this to make sure there are no interferences either between the tool and the part or between parts of the chuck and the rest of the machine. You start the machine. You can hear the tool has just made contact the part. Bring the tool off the end of the part, and then using the dials on the hand feed, you can dial in the desired depth of cut. Now I'll be taking a roughing cut here. I'm taking off about 50 thousandths of an inch. I'm feeding this first pass by hand, just to make sure that nothing very exciting happens. First time you take a cut, you may have bumped something, something may have moved, and the cut you thought you were taking turns out to be much deeper, and by feeding by hand, you can much more quickly stop the feed than you can with the power feeds. Now I've made one roughing cut, and the finish is reasonably good, but there are grooves remaining in the part because I was feeding by hand and was not able to control the speed very accurately. Now I'll take a finishing pass on this part, just a few thousandths of an inch. I'll take 5 thousandths of an inch on this pass, and I will use the power feed. I bring the tool away from the part, engage the power feed, again to make sure nothing very exciting happens. Make sure that the feed is going in the right direction and the speed that I thought it was going to be moving at. Now, having assured myself that the machine is set right, I can bring the tool up close to the part and engage the feed. You can see by the difference in surface finish, and also even here, that the cut is proceeding much more smoothly using the power feed than it was when I was feeding by hand. The last operation you want to perform is called breaking the edge. In the process of turning down the piece of stock, you've left a very sharp edge on the part. Convenient way of turning down this edge is by bringing a tool up in contact with it, with the edge of the tool roughly at 45 degrees to the side of the part. That breaks the edge, leaves a nice smooth surface there that's quite safe. Alternatively, you can use a file to break that edge. When using a file, you should be very careful, especially with short parts, that you don't bump the file into the jaws of the chuck. Now have this part turned down to a desired diameter. This is a parting tool. It's a very long, narrow tool used for cutting deeply into a part, typically used for cutting grooves in parts or cutting pieces off of the end of a larger piece of stock. This tool is held in a special tool holder. You always want to make sure that you minimize the overhang of the tool, using just enough to get through the part that you're working on. So if you need to, if you're cutting off a large piece of stock, you'll be forced to put the tool out further, and this makes the tool very weak. You're very likely to break it. So for the piece that I'm going to be cutting off, part of this demonstration, I need about 3/4 of an inch of the tool hanging out. So I'll set the tool to a length just slightly larger than that to make sure I get all the way through the piece. Lock it in place. And lock it in to the tool post. It's very important that this tool be set perpendicular to the axis of the part. There's several ways of doing this. The most common way is to simply bring the tool into contact with the part and rotate the tool until you see that the tool has contacted the part over its entire length. You then lock the tool post in place. An alternative, if you're using this type of tool holder, is to simply bring the tool holder in contact with the face of the part. And lock the tool post down. Another alternative is to use a dial indicator. If we place the dial indicator near the tool, you can run the tool back and forth and adjust the tool until the dial indicator reading does not change while removing the tool, and then lock the tool into place. Yet another alternative is to bring the tool all the way down here, either in contact with the face of the chuck, or, depending on the type of jaws you have, into contact with the top of one of the jaws. Again, you adjust the tool until you see it coming into full contact with the face of the jaw, and lock it into place. This adjusts the angle of the tool relative to the axis of rotation of the machine. It's also necessary to adjust the vertical position of the tool. This is particularly important when you're cutting off a piece of stock that's solid. In order to cut off a piece of stock that's solid, you must have the tip of the tool exactly coincident with the center line of the part. This type of tool post and tool holder comes with a very convenient way of setting the height of a tool. Loosen up the tool, the holder, and adjust the height of the tool so that the tip of the tool is coincident with the center line of the part. Lock this in place very lightly. This adjustment sees no force during the cutting operation, simply here to set this position. Now that we have that position set, again lock the tool down. We're now ready to cut off a piece of this stock. Turn the chuck to make sure that nothing interferes either between the tool or the part, or between the chuck, particularly between the chuck jaws and the rest of the machine. Turn the machine on and feed the part slowly It's reasonable to cut a groove of about this depth dry. Cutting any deeper puts more and more of the edge of the tool into contact with the sides of the groove, generating heat. So as you go deeper into the part, it's more and more important to use some cutting fluid. Now I'll stop using the cutting fluid for a moment. And you can hear the kind of dry, squeaky sound coming out of the cut. That means that the tool is getting close to binding in the groove and breaking off. You can hear the sound the machine is making change a little bit. Right there, hearing a little squeak. What's going on there is that I've stopped turning the crank, changed the position of my hand on the crank, and during that time, very little cutting goes on and it chatters a little bit. I'm feeding this by hand so that if something unexpected happens, such as the tool binding up, I can very quickly withdraw the tool from the part. Now you can hear the pitch, the chatter go up slightly. That's usually there. You can use that as an indicator. It's just about the time when you'll have completed the cut. You can see here the finish, the cut, about halfway down, you can see that the cut is a little rough and not as shiny. That's the part of the cut where I was not using cutting fluid. It was very clear from this the benefits of using some cutting fluid while you're using the cutoff tool. Drilling a hole in a part on the lathe is done in very much the same way that a part is drilled in a drill press or a milling machine. Start by putting part securely in the chuck. Before turning the machine on, spin the chuck, making sure that there's no interference. In particular, this is very important when you're drilling, because often when you're drilling, you have the compound down very near the chuck. Make sure that you avoid this sort of interference between the jaws, the chuck, and parts of the lathe. Now it's safe to turn the machine on. Going to be putting the drill chuck into the tailstock, the lathe. You can see there's a taper here that inserts into a matching taper in the tailstock. There's a little tang with two flats on it, the end of the taper, that lock in to the inside of the tailstock, keeping this from rotating. You rotate this until the tang fits in place, push it down until it seats, and then with a soft hammer, with the jaws of the chuck that are normally extended, drawn back inside the body of the chuck, very lightly tap the chuck to seat the taper into the tailstock. Now we're ready to start drilling the hole. We start by using a combination center drill. This is a very short, stiff drill. By using this drill first, we guarantee that the beginning of the hole is concentric with the center line of the spindle. We bring the entire tailstock up near the part and then lock the tailstock in place. On this particular machine, this is done with a lever at the back of the tailstock. Other machines may have a lever that operates in this direction. Still other machines will have a lever that's in the front of the tailstock here. When using a center drill, it's almost always a good idea to use a little bit of cutting fluid. This drill doesn't cut as well as a regular drill because it's a compromise between cutting like a regular drill and being very stiff. The result is that the chips that it produces don't clear out of the drill as well because these flutes aren't as deep, nor do they have as much of a twist as a regular drill. Now we have a good, accurate start to the hole. You can see here, if you look closely, that I moved the center drill deep enough into the part so we have a small pilot hole plus a taper. That taper works like a funnel to draw the drill into the center of the hole. It's important to start slowly here. The drill is slightly off-center, and it may be because the tailstock may be slightly out of adjustment. One flute may catch a little bit before the other and pull the drill to the side. So if you start slowly, you could see the drill jump just a little bit as I brought it in contact. You start slowly, the funnel will draw the drill accurately into the center of the hole. Now that the drill is well into the hole, it's drilled down to the bottom of the hole left by the center drill, we can proceed at a much faster rate. The first pass with the drill, I'm going in about 4 or 5 drill diameters. You can hear now a squeaking sound. That's being produced by the drill and the chips because the chips are having a very difficult time riding up through the flutes of the drill and out of the hole and are starting to bind in the hole and producing heat and chattering. So now that I've drawn the drill out and cleared the chips, before I go in again, I should introduce a little bit of cutting fluid into the hole and onto the drill. Now we continue this way, removing about 1 or 2 drill diameters of material each time we run the drill into the hole. The squeaking you hear there is often a very good indication that you've gone far enough with this pass and it's time to remove the drill and clean the chips from the hole and from the flutes of the drill. After you've finished drilling the hole, drill chuck can be removed by drawing tailstock back all the way until it stops. Turn the handle back a little further, and a pin inside the tailstock is there that will press the taper out of the tailstock and release the chuck.